Hey, I wanted to show you my rain gauge setup here at home and show how it functions. I've had it set up outside in a window box for the last couple days, plugged in with my Raspberry Pi, and it's been taking some data. There hasn't been a lot of rain, but it's taken some, so I could see its performance over time, in real time. If you want to come in closer, I'll show you. The rain gauge is out here in the second floor window box. It's propped up with some bricks to keep it from blowing over, and the Raspberry Pi is here in the window sill on the inside, right here. And it's been collecting data. It's hooked up to the internet and sending out to Amazon IoT. Okay, and now I'll show you some of the functionality that I've been recording and the indicator lights that I have set up. Alright, so now that I've shown you my setup for recording information over the last week or so, I'm going to walk you through my Node-RED layout as well as the online API and see some of the functionality of the circuit. So, as you can see here, this is the Node-RED workflow that I built for the project, and we start up here at the top left where with the input from the sensor, which then goes through some mathematical conversions to the inches of rain that are collected over the area of the funnel, and then that is going to be continuously summed up here in this function block, and then it's going to get outputted to Amazon Web Services. It's also going to be sent to our rain metering node, and this is the one that has all of the information for calculating our historical data and current data that we need to update our API. So here it sets up several variables, and then it calculates the hourly statistics, the daily statistics, the weekly statistics, and then the current values here and now. And then that outputs those with special topics, which then get filtered through the switch to be recorded in a SQL database for daily, hourly, and weekly. Update the user interface for the API, and then that information is also sent to a text dump file. I did that. That was an extra step I put in so that in the case that power's lost, it'll be easier to retrieve that information from the text documents which contain arrays, where I could trigger them here with my startup injects, which would populate the UI with the dump file. Kind of a little backup I installed in here. This functionality here is going to watch for the user can set a maximum and minimum threshold, and that will set up global variables, and the global variables are going to constantly be checked against the hourly quantity of rain as it's calculated with each dump. And as the hourly increases, the thresholds will be hit, and it will cause the notification lights to trigger on and off for the LED, and it'll also, at the maximum user threshold, will send an email and a text notification to the user. There is no notification sent for the minimum because it's rainfall, and really there's no point in notifying if there's no rain. So that is basically the Node-RED workflow, and here is the API. You can see that it's populated values over the last week. So this would be starting from the 25th of March all the way to last Monday, so it does a week's worth, beginning every Monday. So this is from Monday the 25th through Sunday the 31st, I believe. And then it's currently tabulating the daily rainfall from the 25th through yesterday. It hasn't recorded today's values yet, so it ends here on Wednesday the 3rd, where we can see we got some rain overnight. And then there's probably also I was testing it, so there's some test values in there. And historical values for today, which I was doing more testing, so you can see in the morning there was probably some rain because we did get rain overnight. But then I was testing it throughout the day as I was finishing out my troubleshooting for Node-RED and any API workflow. So you can see it's been recording every hour. It tabulates the rainfall for that hour. It also shows the current hour's rainfall. So this is how much rainfall has occurred just in this last hour, which has not been added to the table yet. The current daily rainfall, which has not been added to the daily historic. The rainfall for the entire week, which again started on April 1st, Monday, but will not be tabulated in the historical record until the end of the week, which would be Sunday, this coming Sunday, when it gets triggered to record that data. So you can see it keeps a good amount of data. All this data is also stored in arrays within the program as the program runs, and it's also outputted to SQL, and I can show you the database here in a moment. Here are the controls for the user. The user can use a slider to set between 0 and half of an inch maximum rain, and 0 to I have 0.7 inches here for the minimum for some reason. I should make that probably the same. But what happens is you can see this blue light is on, indicating that the current hourly rainfall is below the set value by the user. The set value is 0.13 inches up here by the user, and we're at 0.083. So obviously 0.083 is under the threshold, and that's why the blue minimum light is on. As you can see, it's also on. The LED is also illuminated here on the Raspberry Pi. As you can see, if this value were to decrease below 0.083, the light would turn off, indicating that our current hourly rainfall is no longer below the minimum threshold. I'll put that back where it was. And then the maximum threshold, so we're underneath the maximum threshold because the maximum set by the user here is 0.25 inches and we're at 0.083. So I'm going to increment this so that we exceed the 0.25, and you will be able to see that the green light indicating we're under the minimum will turn off, and then another LED, I believe it is orange, will turn on, indicating that we've exceeded the maximum set by the user. It's going to take a while. That's a big number. So it's increasing the hourly rainfall. There's at 0.099 and increasing. 0.105 with each tip of the bucket, it increases 0.0055 inches. That's the calculated value based on the volume of the bucket tip and the surface area of the collection funnel. So we're at 0.138, we're still under 0.25. 0.155, I might run out of water. Alright, I grabbed some more water so we can get up to our maximum threshold. Sorry about that. And we'll continue pouring. So simulating rainfall. We're at 0.177 with that last tip. And increasing 1.182. I'm probably pouring faster than it would ever normally rain. 0.204, so we're almost there. 0.221, 0.238, 0.243, this last one, maybe two more. There we go. 0.254. The exceeding maximum threshold LED on our user interface is turned on. It's a red color, and on the Raspberry Pi it's indicated by an orange LED for some reason. I picked orange. So that's basically the user interface. Let me show the data storage is in a SQLite database. Also, with the exceeding threshold, the maximum threshold, I forgot to mention that the notification message is set up to send an email and a text message. The functionality is right here, and I receive them here. If you can see, it says weathernode750@gmail.com, maximum rainfall reached, Maximum hourly rainfall has been exceeded. The value is 0.254 inches. That's the email message, and the text message says the same thing. I can pull those up in Outlook as well here, it's bigger. So there's the email message. So the email message here is from weathernode750@gmail.com. It's an account I set up for the weather station, and its content, or its title, says maximum rainfall has been reached, and the body of the email says maximum hourly rainfall exceeded, and it gives the value of the current rainfall at that time, which was 0.254 inches. So there's the communication. I also did receive a text message on my phone through Twilio. I'm going to log in and show the database that is being compiled for all the rain collected. I have my, let me move this down here. I have the total rain is being tallied with every dump starting from a 0 point, and that's collected in this total rain dump file. Also, there are hourly, daily, and weekly dump files. Now these are used to repopulate the user interface in the case that there is a power outage or something else may happen where it's offline. So this is tallying an array of the data for, this one is the daily rainfall that's shown in the user interface. And the same for the weekly and the hourly. So here's the hourly data, and it gives the range of the hours, so 15 to 16, this is in universal time, so that's 3 to 4, 4 to 5, 5 to 6, and so on, and it gives the recorded rain values for those hours. Again, it probably didn't rain, it was me testing at that time, because I don't think we had any rain since this morning. The database here is a SQLite database, as I mentioned, and I'll open it up and you can see that it's populating a table with the epoch time, which is Unix time. It's basically the number of milliseconds that have surpassed since January 1st, 1970. That's epoch time. The value, a numeric value, and the type of value that's being recorded. If we browse the data, you can see that the epoch time is in column 1. The rain value is in column 2, and then what type of rain value that was being recorded. This is the daily rain at that time, but you can see down here there is hourly rains, lots of hourly rains, and this has been recording ever since I turned it on, so there's quite a bit of data in here. And that is my rain gauge project. Thanks.